Hi, in my previous video I discussed the electron volt. That is, the electron volt is a unit for energy and it's equivalent to 1.6 by 10 to the negative 19 joule. But why do particle physicists refer to the electron volt as a unit for mass? For example, in 2012, CERN announced the discovery of the Higgs boson, and they announced its mass as around 125.8 giga electron volts. Now, to give you a sense of understanding how big that is, a proton has a mass of around 0.931 giga electron volts. So the Higgs boson is significantly more massive than a proton. But why are they using the electron volt? Why not kilograms? Well, let me explain. To start off, let's remind ourselves that mass and energy are actually equivalent. That is, one can convert into the other, and of course it's combined by our famous formula E equals mc squared. Now, in terms of the units that we normally use for energy is joules, kilograms for mass, and c squared, of course, is meters per second, and then, of course, that is squared. But what we want to do is we want to convert them down into our electron volt value here. And then what we're going to do is we're going to rearrange that. So let's rearrange this first. So we know that mass equivalent is equal to energy over c squared. What that means is that this mass in kilograms is this in joules, right? Divided by this particular value over here. And what we want to do is that we want this in terms of what is equivalent in terms of the electron volt. So what we do is to say, well, what's the energy? Well, the energy, of course, is in terms of our work done, and remember we're making that 1 electron volt, and that is, of course, equal to the charge multiplied by the voltage that charge moves across. So we get QV, and of course we get C squared down the bottom. Now Q is equal to 1.6 by 10 to the power of negative 19. This is still 1, our 1 volt, and of course down the bottom we have C squared, and of course that is 2.99792.458 meters per second, and of course all of that is squared. If you do the math, if you work this out, you're going to get a value for the mass of what this is equivalent to in terms of kilograms. Now, what is that value? It ends up being 1.782 by 10 to the power of negative 36 kilograms. So in other words, what we're saying is 1 electron volt per c squared is equivalent to 1.782 by 10 to the power of negative 36 kilograms. Now I want to make this point. The actual equivalent in terms of mass is that the 1 electron volt per c squared is equivalent to that value in mass. But what we often do, particularly in particle physics, is we drop that off. But if you are talking about mass, it's an assumption that that is there. So when I said that the Higgs boson had a mass of 125.8 giga electron volts, that's often how they talk about it. But in reality, if you look it up, you'll see that it's actually quoted as 125.8 giga electron volts per c squared. So that's actually the conversion that we have here. So what about the mass of an electron, for example? Well, the mass of an electron is equal to 9.1 by 10 to the power of negative 31. How do I convert that to our electron volt term? Well, if I divide this here by my value of my mass, I'll get the equivalent mass in terms of electron volts. Now what's that value? I'm going to get 0.51 mega electron volts. Or in other words, what we're saying is 0.51 times 10 to the power of 6 electron volts. Remember, this is actually over c squared, but sometimes it's just not mentioned because it's assumed knowledge that when you're talking about the mass, that's already there. What about our proton? Our mass of our proton is equal to around 1.67 by 10 to the power of negative 27. It's considerably more massive, and then if you did the calculation, you're going to get the value I quoted earlier, which is 0.931 giga electron volts. So in this case, it's almost 1 giga electron volt, or almost 1 billion electron volts. Now, why is that useful? Well, let's say I have two particles colliding, such as at the CERN Large Hadron Collider. We have protons colliding and they create a whole spray of particles. Well, if you want to know how much energy that converts into in terms of E equals mc squared, what happens is that this number becomes very useful. So let's say this is the value here. Now remember, the energy is already that value without the c squared. So in other words, when I get two protons colliding, I get 2 times 0.931 giga electron volts, and that results in 1.87 giga electron volts. Notice here I am dropping off the c squared because that c squared tells us its mass. If I multiply it by c squared, I automatically get its energy. And you can see the numbers are nice and simple now, because now all I need to say, okay, two protons are colliding, it produces energy, E equals mc squared, by that particular value. Now mass isn't the only dimension where the electron volt is used. It can also be used in distance, momentum, and even temperature, but that's probably a topic for other videos. Well, I hope that has helped you understand why physicists use the electron volt for a unit for mass, but more correctly, the electron volt per c squared. Please like, share, and subscribe. Ring the bell, drop a comment down below if it has been helpful for you. Consider supporting me via Patreon. My name is Paul from High School Physics Explained and Physics High. Bye for now.